alteration index as previously where we stopped. So please just hit the red button below this video so that next time you can be able to receive the next following session. Further. So this measure color changes of polymorph as a function of maturity. The scales of thermal alteration has been estimated to be vitrinite reflectance maturity scale. So we know the color of vitrinite reflected, so amount of light reflected by vitrinite is seen to increase with increasing the maturity of the hydrocarbon. So vitrinite reflectance and thermal alteration index are not quite different. So geochemical fossils, or we can call them biomarkers. These are biomarkers and are maturity indicators during the evaluation of source rock. So this is based on the pristine and fighting ratio as shown in the figure below. So maturity, we observe the amount of biomarkers always increase with increasing maturity. So when you see the amount of biomarkers, for example, pristine and fighting is very high during analysis process, therefore we can easily conclude that our organic matter is mature. So this one basically explaining the Van Crevelen diagram. Now here in the vertical axis we have the hydrogen index, and in the horizontal axis we have oxygen index. So this is our first curve here down here. This is representing the type 3 kerogen. We observe that this curve has very high oxygen carbon ratio but very low hydrogen carbon ratio. So this type of kerogen is not always good. That's why you observe that type 3 kerogen is always associated with gas and is always derived from terrestrial organisms or terrestrial organic matter. Then you observe that for type 1 and type 2 kerogen, for them they have very high hydrogen carbon ratio but very low oxygen carbon ratio. For example, type 1 has very low oxygen carbon ratio but very high hydrogen carbon ratio. And we observe that for this type of kerogen, type 1 and type 2 kerogen, they are all oil prone, they are capable of generating oil. So you observe that just from here, we observe that if we have intermix between type 2 and type 3 kerogen, means that organic matter kerogen is capable of generating both oil and gas. We have type 1 and type 3, still means now when you have all of them together means we are capable of generating both oil and gas. So kerogen fluorescence is very important for kerogen maturity indication when measurements are done on specified algo constituent. We know kerogen tend to fluorescent. So most fluorescent disappears and becomes maturity indicator rather early at reflectance level of about 1%. So meaning that kerogen fluorescence really cannot be relied on as a maturity indicator. We know increase in fluorescence is an indicator that maturity is increasing maturity. Although you cannot rely on fluorescence because it becomes useless at reflectance level of about 1%. So conodon alteration index. Although conodon is composed of carbonate apatite, changes in conodon colors apparently due to carbonization of inclusion of small amounts of organic matter during catagenesis and metagenesis. So change in conodon color can also be a very good indicator of maturity. So advantages of conodon alteration index. They provide a means of measuring maturity levels in rocks that do not have fallen grains or vitrinite. So in rocks that we don't have fallen grains and vitrinite in them, so we can use conodon as a maturity indicator. Then conodon alteration index measurements are more sensitive at higher maturity levels than can be realized for thermal alteration index. So meaning that conodon alteration index, when at higher maturity levels, they are become more sensitive compared to thermal alteration index. For example, when you look at vitrinite reflectance. So cold alteration index is inexpensive and cheap to measure. Then disadvantages of Coulomb alteration index. Coulomb alteration index values can be dramatically increased in the presence of hot brains. So in presence of hot brains, there is a dramatic increase in Coulomb alteration index. Coulomb do not occur in rocks younger than the Triassic and hence is of less use in most areas. Then electron spin resonance, a process for predicting the presence and maturity of hydrocarbon material present by initially treating a number of rock samples derived from an exploratory well or surface outcrops to remove certain materials therefrom, including carbonates and layered silicates. The samples are thus prepared and then subjected to observation of paramagnetic resonance, so electron spin resonance. Properties of the kerogen entrapped in the samples, and from these properties the maximum thermal stress of the samples are evaluated and the maximum geothermal gradient for the formation is derived. So the maximum geothermal gradient is extrapolated to a depth of interest to predict the type of hydrocarbon production, if any, which may be reasonably contemplated from that depth in the formation. So electron spin resonance is a tool which can be used to infer maturity of the hydrocarbons which are present. For example, we observe that electron spin resonance is a phenomenon that occurs in an atom in such a way that we know that for every atom they always possess electrons, and each electron in an atom occupies a given principal quantum number. And the principal quantum number we know that relates to the energy levels which are present in the different atoms. But we observe that the presence of a paramagnetic field or a magnetic field from an external source which is exerted on this electron, the energy level of an atom become split into two, and therefore the electron tends to occupy the space between the two energy levels. And because of that kind of behavior, we cannot be sure really where the electron is going between the two energy levels which are formed from the parent energy level. So in that state, the electron is said to be in a state of resonance. So if in the presence of our kerogen and the electron is capable of absorbing a photon from the kerogen, you observe that a photon is equivalent to a given quanta of energy which an electron can absorb. So when that electron absorbs that energy from the photon from our kerogen, you observe that the electron can be excited and jumps to a higher energy level. And when the electron jumps to a higher energy level, therefore this puts the atom in a state of, makes the atoms to be excited, and in that case that movement from electron from a lower energy level to that higher energy level gives the atom excited. So therefore the tool automatically records a spectrum which is also an indicator of maturity. It now gives us an indicator that the instrument has absorbed light energy from surrounding and the energy is taken by the electron. So therefore with the energy which is absorbed and the excited electron due to that absorption and light that it produces, so therefore the amount of light absorbed by electron now is directly proportional to the maturity of our organic matter or kerogen. From that we can now infer the depth of burial which maybe organic matter was buried, and also we can also infer the geothermal gradient, and from the geothermal gradient we can predict the temperature or barrier of the organic matter. So prior to that, we can be able to know our